Hi, welcome to part 1 of the Godot Tactics tutorial, War of the Tactics Tutorial Conversion, Intro and Setup. This is Digital Workbench and I'm 7th Sage. In this intro to the series, we'll be setting up our project and getting the basic art assets ready to be used later in the series. Before I get too deep into that, I'd like to give a quick overview of what this project is and who I am. If you'd like to skip directly to the tutorial portion, I've left timestamps below. So what is this? This is a conversion of the tactics tutorial at theliquidfire.com from Unity in C# to the Godot engine in GDScript. I've been posting written versions of each lesson on the site as a guest author for a while now, and I'm at the moment around 2/3 of the way through the series. So if you'd like to see the written version or look ahead, feel free to check out the site there. I'll leave a link in the description. In the background, you can see Unity and Godot versions playing side by side. As you can see, I've tried to keep it as similar to the original as possible, both graphically and code-wise. In my opinion, there are only two really good, feature-rich tactics tutorials available. The one on theliquidfire.com and a paid course by CodeMonkey on GameDev.tv. Both are excellent. Liquid Fire is a more Final Fantasy Tactics-like experience, and CodeMonkey is a more XCOM-like game. The only downside is that both of these courses are made in Unity, which over the past couple of years has a somewhat shaky history. My goal is to faithfully reproduce as much of the original tutorial as possible, though there will be some small tweaks and fixes, and with any luck, not too many new bugs. While Unity and Godot have a number of differences, I've found that for the most part, I've been able to keep the code looking fairly close. So if you've followed along with the Unity version at all, things should look familiar. And any changes made to the Unity version will look similar in Godot. So, who am I? I'm a hobbyist 3D artist and programmer. I've been in love with tactics/strategy RPGs since Shining Force 2 came out on the Sega Genesis and Final Fantasy Tactics on the original PlayStation, and I'm excited to play the new version. I've been dabbling at creating my own game for ages, starting with RPG Maker back when the only English version was not officially available. Jumping to 3D, I went into the deep end and used Ogre 3D for a while using C++. After not having much luck getting the lighting and shadows to play nicely, I moved on to Unreal and Unity. I liked Unreal used C++, but my video card also did not play nicely with Unreal. It was too old and slow and didn't like all the fancy graphics. While Unity might not be as efficient, it played better with my system, and I found this really nice tutorial for a tactics game on theliquidfire.com. As for Unity, I started to get nervous when they merged with IronSource. Around that time is when I first heard about Godot. I knew a lot of people that switched then, but I still held out. I was on the edge though. After that, there was the whole runtime fee thing, where I finally decided it was time to move on, and the Godot community seemed fairly strong, so over I went. So I'll hang out in Godot for at least a while. If you'd like to find me around the web or support me in some way, here are the main places you can find me, and I'll leave links in the description. Let's start by going to the Godot website at godotengine.org. Currently, the newest stable release is 4.5, which is what I'm going to grab for now. For this tutorial, it doesn't matter if you choose the standard or .NET version. They are both basically the same, except the .NET version will allow you to create scripts in both GDScript and C#, while the standard will only let you code in GDScript. I've gotten most of the way through the written version, so I think at this point, I can confidently say that for this tutorial, GDScript is more than capable, so I won't be getting into any C# this time around. If you'd like to use an older version, you can find links to all previous versions archived on the website. We'll be using Godot 4 for this tutorial. In the written version on theliquidfire.com, I'm using Godot 4.1 exclusively, but for videos, I'll be using 4.5 and beyond. likely upgrading as the series progresses. This way, I hope to keep the tutorial more current and in the process show that it works and hopefully all versions between 4.1 and beyond. One thing to note about Godot is that it does not come as an installer. The entire engine is inside the zip file ready to go. So to install it, we just need to find a safe place to put it and maybe create a shortcut. For me, I created a folder named dev and moved the files there. To make it easier to access later, I pinned the executable to the start menu. If you are on a Mac or Linux, your process may be slightly different. From there, we just need to click the icon and open the engine. If you chose the .NET version and get an error, you will need to download the .NET SDK from Microsoft. Once we have the editor installed and opened up, let's create our project. I'll be naming the project Godot Tactics and choose a location to save your project. For me, the default location is fine. There are a few different options for graphics pipeline. We aren't getting into anything complicated there, so choose whichever option you'd like to work with. I'll choose Forward Plus. If you use Git, you can set that here so the engine will automatically create your .gitignore file and such. I'm going to keep folder organization pretty close to the original. Keeping organized is important, especially for a large project like this. To create a folder, right-click inside the File System pane and select New Folder and add these folders: Add-ons, Data, Materials, Prefabs, Scenes, Scripts, Settings, and Textures. One small difference we'll be using here is that instead of an editor folder, we'll be using add-ons, as this is the default editor plugin directory for Godot. We're also not bound to using the resources folder like we are in Unity, so I'm going to use the folder data instead, since that makes more sense to me. Resources just feels like it should be things like 3D models and textures, but if you want to stick with the original, that's fine. We'll add a few more folders inside these as we continue the project. We'll be using the art and textures from the original Unity tutorial for the most part. I've also included an icon that you can use for the project that I modified to fit our needs, originally created by 3D Pyramid under the CC0 license. I'll provide the links in the description. Inside the textures folder, create another folder named UI and place all the textures inside that except for dirt.png, which will go into the textures folder itself. In 4.1, it wasn't possible to drag files directly from a zip file into the project window. In 4.5, that no longer appears to be the case, though I'm not sure which version in between that changed. So if you are on a version somewhere between the two, you may or may not be able to move files directly from the zip. Icon.svg, we will replace the default file in the root folder. While we were talking about assets, I was curious about what font was used in the original game for the height display. It won't be used in the tutorial, but I thought others may be interested in it as well. The font is called Bradley, created in 1895. Adobe has a nice version of it called Bradley DJR, and there is a free version that someone else made as well called Bradley Gratis. Some of the curves are a bit too sharp, but it's still very good. Also, while this isn't exact, I found these values to be fairly similar to to our gradient effect. Hex EF F8A1, hex 98 F5 9A, and hex 71 DD-BB. In Godot, slicing a sprite is done on the object level instead of inside the texture, so we'll put off that until we need it. But for now, there are a few materials that we need for our 3D objects. We'll start with the dirt texture. Right-click on the Materials folder and choose Create New Resource. In the search field, type in Material and choose Standard Materials 3D. Click Create and give it a name, dirt.tres. Similar to Unity, our settings will be in the inspector. There are a couple settings we need to change. Under Albedo, there is a field for texture. Click that and select Load and locate the dirt.png texture in the file browser. We can also drag the file directly from the File System pane onto the texture field. Under UV1, we need to set the scaling. In Unity, the basic cube uses the same texture for all faces, but in Godot, each face is unique. So to tile the texture so the complete texture is on each face, set the U, V, and W values to 3, 2, and 1 respectively. You will need to click the chain icon to allow non-uniform scaling. The last value we need to change is the roughness to 1, the opposite of the Unity tutorial where we set the smoothness to 0. Last, let's click the save icon at the top. The engine will also save the material if we click Save Scene. With the first material done, let's create the rest of the materials we need for now. Ally, enemy, eyes, and selection. Next are the two materials for the hero and enemy units. These ones don't need any scaling. For ally, give it a green color on the albedo, such as RGB 86, 200, 88. Hex 56, C8, 58. And I think roughness of around 0.5 looks similar to the original. For the enemy, give it a red color on the albedo, such as RGB 183, 43, 61, or hex B7, 2B, 3D, and the same 0.5 roughness. Both the allies and enemies will use the same texture for the eyes. We'll leave it a white color. The last material is for the selection indicator. To give it a yellow color, we'll set the albedo to something like RGB 255, 255, 0, or hex FF, FF, 00. Last thing left for now is to create the prefabs we'll be using. Here is an area where Godot differs a little bit. In Godot, everything is basically a node. Even scenes are a node. In fact, for object prefabs, what we'll be creating are scenes that will instantiate nested into our main scene. So let's create the first one. Right-click on the prefabs folder and create new scene. And for the root type, select 3D scene and give it a name, tile, and select .tscn in the dropdown for type. In the scene panel, right-click on the tile node and click Add Child Node. Type in Mesh in the search and select Mesh Instance 3D. In the Inspector tab, under where it says Mesh Instance 3D, for the Mesh field, select New Box Mesh from the dropdown. To add the material, we can drag dirt.tres from the file system pane onto the object in the scene, or you can look at the mesh in the inspector and under the geometry field, find the field material underscore override and click on the drop down and select load. From there, find the materials dirt.tres, save the scene, click on the options menu option scene at the top and select save scene. The next few meshes require us building up several meshes and scaling and positioning them, and while these specific objects won't be affected, it's a good time to discuss the difference in Unity and Godot's coordinate system. Both Unity and Godot are Y-up systems, meaning our ground plane will still be on the X and Z axis. However, Unity is a left-handed coordinate system and Godot is right-handed. What this basically means is that the X-axis is mirrored from Unity. Since our objects are mirrored anyway, it won't matter that we're doing the board in a different order. For the most part, aside from positive X going left instead of right, we won't notice much of a difference in the project aside from a couple variables in the camera and input. Right-click on the prefabs folder and create another scene. Name this one Hero. In the Scene tab, right-click on the Hero node and add a new child node. Scroll to the top and choose the type Node 3D. Right-click on the node and rename the new node Jumper. Next, add a new child node to Jumper. Search for Mesh and again, choose Mesh Instance 3D. This will be the main body. Give it a name, something like Body. We won't be referencing this directly in code, so the name here is more for organization. This time, in the inspector, instead of choosing Box Mesh under the category Mesh Instance 3D Mesh, choose New Sphere Mesh. Scroll down in the inspector to the section that says Node 3D. Expand the section that says Transform and change the scale of the sphere to XYZ 0.8, 0.8, 0.8. Like before, under the geometry field, find the field material underscore override and click on the drop-down and select Load the material ally.tres. Next, create a child node for the body and name it I. For the type, choose Mesh Instance 3D again, and in the inspector under Mesh Instance 3D Mesh, choose New Sphere Mesh again. This time, set the scale to XYZ 0.25, 0.25, 0.25. And still, in the transform section, set the position to XYZ 0.17, 0.32, 0.3. Set the material override to eyes.tres. Once finished, right-click on the eye node and choose Duplicate. Click on the new eye and under the transform, change the position to XYZ negative 0.17, 0.32, 0.3. Save the scene. Once the scene is saved, right-click on the hero.tscn file in the prefabs folder and select Duplicate. Give it the name monster.tscn. Open the new scene and select the body. Under Geometry, Material underscore override, load the material enemy.tres. Save the scene. The last object we'll make is the tile selection indicator. Create a new scene in the prefabs and name it Tile Selection Indicator. Create a new child node with the type Mesh Instance 3D, and for the mesh type this time, we'll choose Box Mesh again. Give the box the material selection.tres. Under Transform, change the scale of the box to XYZ 0.1, 0.1, 0.3. Again, you'll have to click the chain to allow non-uniform scaling. Don't worry about setting the position or rotation. We'll do that in the next step. Duplicate the box until you have 8 in total. Be sure you've set the material and scale before duplicating. Otherwise, you'll have to set it on each individual box one at a time. We'll use the same values that the Unity version used. Because the shape we were creating is symmetrical, we don't really care that our axis is mirrored. Once you're done, save the scene, and that completes all the setup we need to do. If you have any questions, feel free to comment below. I've left links in the description below to all the files and links mentioned in the video. I've also created a GitHub repository for specifically the video version of this tutorial, and you can use that to follow along, or you can use the original repo from the written version on theliquidfire.com. For the most part, I'll keep them both the same, but I'll be making some small tweaks in the video series, and I'll be using a later version of the engine. If you'd like to be notified of when the next video comes out, be sure to like and subscribe and hit the notification bell. If you'd like to show some support to the original creator of the tutorial series, John, check out his website, theliquidfire.com, for the Unity version of this tutorial and more. Or find him on Patreon at patreon.com/theliquidfire. Thanks for watching.